Hi, I'm Mr. Franklin, and in this video, we're going to talk about metric conversions, the metric system from a basic standpoint, and in a follow-up video, we'll go into a more advanced version that might be more applicable to chemistry or more advanced physics. So the metric system, or SI units of measurement, by the time you get to high school, you've heard of it, you've worked with it before, but kind of a review, because we are going to be going deeper with it, is a fundamental quantity is a quantity from which other quantities may be derived. For example, length and time are fundamental quantities from which we get the unit of, or the measurement of speed. In the metric system, we have a base unit, which is the unit of measurement used to measure a fundamental quantity. And these are decided by a body of scientists that basically come together and decide what actually equates to the measurement of a kilogram, or the unit of length, which is the meter. What distance actually is that? We'll talk about that more in a second. But here is a list of the 7 fundamental quantities from which all other quantities are derived. So we have, first, we got to realize that quantity is a word that means we're going to measure something that means something very specific. And we'll get into these more as we go, but mass has a symbol for m, so that's usually the variable we use, but we measure it in kilograms, and the symbol for kilograms is we have kilo, and then we have grams. And that one's probably the only one that's a little weird in this list. The next one is length, which usually a cursive L, if you can handwrite it. Bottom line is we measure it in meters. There's the British spelling of meters. For time, we use the variable for T for time and S for seconds. So seconds is what we measure time in. Current is measured, has the unit of, that's a capital I actually, which is why I prefer to use the capital L for length, so that we're making a distinction between these two. And we measure current with amperes. We will get to that at the end of this year. Temperature is measured in Kelvin. It's not degrees Kelvin, it's just Kelvin, and it's a capital K. Amount of substance is measured in moles. You'll learn all about that in chemistry, and we shortcut it to MOL. What a great shortening. It's short like that so we don't confuse it with the M or the M. So we got meter, we got mass, so we just drop the E on the end of that one. Luminous intensity, it's I for intensity. And then we have the candela. So in this class, we are going to use those. We will talk about this one. We won't use it a whole lot. And that'll be mostly where we spend our time, is in these base units. And we'll spend probably 75% of our time up here, or in derived units. Okay, so let's jump into kind of the meat of what we're going to talk about. And I hope this is familiar to you, but I want to give you some hints and clues to make this go a little faster and to work through it. So when we get into the metric system, one of the great things about the metric system is we decide whatever our base unit is, and we say, if we have multiples of 10 of these, we give it a prefix. So for example, if my base unit is the meter, if I have 10 meters, I could actually use the word deca instead of saying the word 10. So I could say decameter. So if I have 1 decameter, then I have 10 meters. So we use the prefix to represent bigger and bigger, or smaller and smaller numbers of things. So if I use the word kilometer, which we say kilometer in the United States, so kilometer, kilometer, that means literally it's 1,000 meters. So if you travel 1,000 meters, you travel 1 kilometer. Why do we do that? Because kilometers make really big numbers easier to talk about. So that's really the whole reason we're going to use these prefixes. It takes numbers that are difficult to manage and turns them into things that we can measure and work with. So we have kilo, hecta, deca, the base unit, whatever it is, and then we have deci. So when we go below the base unit here with deci, that means fractions. So this is a tenth of a meter. A deci is a tenth of a meter. And then centi would be a hundredth of a meter. So we could have a centimeter. So 1 centimeter is equal to 1/100th of a meter. If I have 100 centimeters, I will actually have 1 meter in length. And we're going to show you this with a specific example in a second. Milli means 1,000. Okay, so millimeter is 1,000. We can also apply these to our other base units. So we can have a milligram. So a milligram is 1,000th of a gram. Okay, it's a fraction, it's a decimal. A milliliter is 1,000th of a liter. We can have milliseconds. We can have milliamps, is actually how we would say it. We can have the milliampere, which means we have 1,000th of an amp. And so all of these prefixes can work with all these: kilometer, kilogram, kiloliter, kilosecond, kiloampere. You'll notice that we will probably rarely use any prefixes with seconds in this class. We will also probably only use kilo, the base unit, centi, and milli for this class, because we'll be keeping it simple. There are actually units, if you watch the follow-on video, where we go beyond those, and you will use those for chemistry for sure. How do I remember this? So this is something you really should just lock in your brain and just know. I learned it way back when, and I still remember it from what I learned back then. And there's a little memory device here. It's called a mnemonic, and it's King Henry died by drinking chocolate milk. You might hear a different word here in the middle, but it's King Henry died by drinking chocolate milk. So King for kilo, Henry for hecta, died for deca, by for the base unit. Okay. Some people use while or something else, but it stands for one of these. So the meter actually goes here. That's the base unit, or the gram. Okay, so the base unit goes there. King Henry died by drinking chocolate milk, which later, when you're working on a problem by yourself, you can just write King Henry died by drinking chocolate milk. Some people write it horizontally, and some people write it just vertically. I prefer the staircase because I get less confused when it becomes time to do a conversion. So there's a reason I write it at an angle. And so I would say until you get more familiar with what's going on, you should do the same.